The mysterious journey of stars. How do they live and vanish? Stars are the wonders of the universe, not only providing light and energy, but also holding the mysteries of formation, evolution, and demise. Each star is a story of life and death, existing not in isolation but deeply influencing the structure and development of the cosmos. Born from clouds of dust and gas, stars undergo billions of years of complex physical phenomena. This journey is not just a physical one, but also a source of inspiration for profound scientific questions about the nature of the universe and ourselves. The birth of stars. Stars are born from clouds of gas and dust in space, known as nebulae. These are regions where large amounts of hydrogen, helium, and cosmic dust gather, often stretching over hundreds of light years. Initially, these clouds are in a relatively stable state, but when an external event, such as a shock wave from a nearby supernova explosion, causes disruption, the particles begin to be pulled together by gravitational forces. This process causes the gas and dust in the nebula to compress, increasing pressure and temperature at the center. When the temperature reaches about 10 million Kelvin, the first nuclear fusion reactions occur. Hydrogen is burned to form helium, releasing an immense amount of energy. This marks the moment when a star is officially ignited. A prominent example of this process is the Orion Nebula, where new stars are constantly being formed in a vast region of space, about 1,350 light-years away from us. The Eagle Nebula, with its famous pillars of creation, is also a place where the early stages of star birth are taking place. Astronomers have used the most powerful telescopes to observe and study these areas, providing valuable insights into the early stages of a star's journey. The life cycle and evolution of stars. When a star is formed, it enters a phase called the main sequence, the most stable and longest phase of its life. During this phase, the inward gravitational force of the star is balanced by the radiation pressure from nuclear fusion reactions in its core. This is the phase in which the star shines steadily, providing light and energy to the surrounding space. Our Sun is currently in the main sequence phase and has been in this stable state for about 4.6 billion years. Scientists predict that the Sun will continue to remain in this stable state for about another 5 billion years before entering the next phase. After using up the hydrogen in its core, the star begins to enter its aging phase. At this point, the core of the star contracts, while the outer layers of gas expand, forming a red giant. Stars like Betelgeuse, a red supergiant in the Orion constellation, are in the final stages of their lives and serve as a typical example of this phenomenon. During this phase, the star burns heavier elements like helium, carbon, and oxygen, creating a series of complex reactions before reaching its final end. The end of a star's life depends largely on its initial mass. Smaller stars with masses less than 8 times that of the Sun typically end their lives as white dwarfs, a hot remnant core that no longer has enough energy to carry out nuclear fusion. In contrast, more massive stars undergo a supernova explosion, releasing a vast amount of energy in just a few seconds, shining brighter than an entire galaxy for a short period. After the explosion, the remaining core of the star can become a neutron star or, if the mass is large enough, collapse into a black hole, one of the most mysterious phenomena in the universe. Strange phenomena in the death of a star. Supernova SN 1987A, observed in 1987, is a classic example of the power of a star's explosion. This event provided scientists with a treasure trove of information about the evolution of massive stars and their impact on the surrounding environment. In addition, neutron stars and pulsars, with their incredibly dense matter and extremely strong magnetic fields, continue to raise significant questions about the nature of matter and the fundamental forces in the universe. Neutron stars, with their extreme density, may be tiny, but they contain enormous mass. A teaspoon of neutron star material weighs billions of tons. If a neutron star spins rapidly, it emits periodic radiation beams, known as a pulsar. A prime example is the pulsar in the Crab Nebula, which rotates at 30 times per second and emits energy millions of times greater than that of the Sun. Moreover, black holes, the final result of massive stars, are the most fascinating phenomenon in astrophysics. The immense gravity of a black hole is so strong that not even light can escape, creating mysteries that modern science has yet to fully solve. New theories about stars. The journey of stars doesn't stop at what is already known. Scientists are exploring exciting new theories. Dark matter stars. A type of star is believed to exist but has never been directly observed, possibly made of dark matter. These stars could be the key to understanding more about the universe. Reborn stars. Can white dwarfs be reborn by gathering additional matter from their surroundings and becoming a new star? This could completely change our understanding of the life cycle of stars. The role of stars in life. Stars are not only sources of light, but also the chemical factories of the universe, creating the heavy elements essential for life. Carbon, oxygen, iron, all the elements that make up our bodies, are formed through nuclear fusion in the core of stars. When stars die, these elements are released into space, becoming the building blocks for planets, moons, and ultimately, life. The journey of stars is a miraculous story, from their birth in nebulae, shining brightly for billions of years, to their violent death, all reflecting the universe's incredible cycle of rebirth. Stars not only help us understand the universe, but also connect us to the very origins of life. Continuing to study stars will open new horizons, bringing humanity closer to the secrets of the vast cosmos.